Hey, stats class, here's the official meter stick illustration for you. So the basic idea of this warm-up is imagine a whole bunch of points in a scatter plot. Imagine I choose two of them. So maybe I choose this point right here and this point right here, and I find the slope. And the question is, how does the variation in X affect the slope, and how does the variation in Y affect the slope? So the meter stick, here we go. So if my X's are really close together, and a little tiny change in Y makes a big difference in the slope. That's the meter stick example. If the X's are far apart, a little tiny change in Y doesn't make a big difference in the slope. Even a slightly bigger change in Y doesn't make a big difference. So X's being far apart makes a more stable slope. Okay, that's the X's. Now let's think about Y's. If the Y's vary a lot, that causes the slope to vary a lot. If the Y's vary a little, that causes the slope to vary a little. So basically, we want the Y's to not vary very much, and we want the X's to be far apart. So what does that do to our data gathering? If we are gathering data, we want our explanatory variable values to be as far apart as possible. Say, for instance, I'm testing the temperature of an oven. I want to know if I'm going to put a thermometer in the oven and I'm going to set it to a certain temperature and see how accurate that is. If I only test like from 350 to 400, I don't get very good results because there's a lot of variation there. But if I test all the possible temperatures that the oven could be set to, I get a more accurate prediction of how those variables are related. On the other hand, I want my Y's to not vary very much. So I want a really accurate thermometer put in the oven so that that's not going to make a big difference. So X's, we want them to vary a lot. Y's, we want them to be very stable.